Greetings of the day. Welcome, dear students. Let us begin with a new course which is called as Digital Communication, and this is going to be dealt for you people in this particular semester. The course code is 304181. Yes, please note down 304181. And there are 6 units in this. We will be looking into all the 6 units one by one. Before starting with the contents of Unit 1, I would like to tell you that there are 6 course outcomes here which I have classified. The first course outcome is you'll have to solve the problems on source coding methods. The second course outcome is analyze the channel blocks for digital communication. Third course outcome is stated as determine the challenges of random noise in digital communication system. The fourth course outcome is stated as select the baseband receiver for received input. Fifth one, distinguish between passband receivers. And the sixth course outcome is determine the use of spread spectrum technology. Alright, what are we waiting for? Let us start with our unit 1, which is named as digital transmission of analog signals. In this slide, you can see that the syllabus is mentioned here. You just go through this, okay, and we will be picking up each point one by one. To begin with, I would like to talk about the basics, and that is the block diagram of digital communication system. Okay, this is what the block diagram of a digital communication system looks like. Primarily, it comprises of two major parts, a transmitter part and a receiver part. Alright, if you're looking at the transmitter part, definitely and obviously the input source or you are supposed to give some input source, right? So the input could be in the form of audio signals, it could be in the form of video signals, image, text, whatever. Okay, and the second block you can see here is your source encoder. We'll deal with these blocks one by one in detail. Then you have something called as channel encoding, followed by digital modulator, and then whatever signals are going to be produced, they are going to be sent via or transmitted via the antenna. Before I start, I would like to tell you one thing. Please remember, the transmitter and the receiver need to remain in sync. That means they need to be synchronized. Alright, let us take up the first block for discussion, that is your information source and input transducer. So the information source, as I told you, could be of different types. It could be audio, it could be video, it could be image, it could be discrete data, whatever. This forms your input. Okay, why we are having that input transducer there as a part? Because some of the signals might not be electrical signals, so they need to be converted into electrical signals. Hence, the inclusion of transducer in the first block. Alright, so the output of your first block would be nothing but primarily a analog signal, or it could be a digital signal. Yes, it is going to be electrical signal in nature by default. Now the second block is your source encoder. Okay, why do we need source encoding? Yeah, because we need to, yes, reduce the redundancy, and definitely anybody nowadays is looking for bandwidth efficiency, right? So this is the major work of your source encoder. Okay, at the output of the source encoder, you might end up having digital signal, or you might end up having analog signal, right? If it is digital signal, then we are going to do data compression, and the data compression could be of different types, like Huffman coding. You can go for using Shannon-Fano coding, etc. We're not discussing all these things right now. Okay, the next part, at the output of a source encoder, if it's not a digital signal, if it is supposing a analog data, then you can use ADM, okay, that is adaptive delta modulation, or delta modulation itself, or pulse code modulation, etc. Okay, in short, I would conclude by saying that source encoder block output would be a digital signal. Then let us come to channel encoding. Okay, what is the necessity of this channel encoding block? The major answer or the major point to be discussed here is noise immunity. Yes, and noise immunity can be obtained through block code, or you can go for using cyclic code, all of these things. Okay, there are many other types, we will not discuss them here. Okay, and then definitely the output, again if I have to discuss, it is at the output of the channel encoder you are having a digital signal. Then you are having a block called as digital modulator, which takes the input coming from the channel encoder, converts this low frequency or these electrical signals to very high frequency modulated signals. Okay, the job of digital modulator, I'll repeat, converts electrical signals to high frequency modulated signals, and the method used for this would be ASK, PSK, FSK. Okay, so this is what I just happened to discuss now. It is about the transmitter part. Okay, you can just have a look at what all is being discussed about the transmitter in this part, where I have mentioned that information is audio, video, image, discrete data, whatever. Why we are using source encoder block there? In order to reduce the redundancy and to improve the bandwidth efficiency. Why digital data? Yes, if it is digital data, then it is you're going to do data compression using the different methods available, Huffman coding or Shannon-Fano coding, or maybe so many other methods that are available. And if the output is in the form of analog data, I'm talking about the output of source encoder block. Yes, definitely. So the analog data would be dealt by adaptive delta modulation or delta modulation or pulse code modulation, etc. Okay, then if you want to talk about the reduction in noise immunity, there are different methods as I discussed: block code, cyclic code, and all of these things. Alright, and we have also talked about the digital modulator, which converts the electrical signals used into high frequency modulated signals. The methods used are ASK, PSK, FSK, all of these things. As far as a receiver is concerned, it is going to work exactly in contrast to the transmitter. So whatever discussions I have done of each of these blocks in the transmitter section, it is going to be complicating, it would be replicating. The receiver blocks would be replicating the job. See, if we are talking about the channel decoder here, it is going to be working exactly opposite to channel encoder here. What does source decoder do? Exactly the reverse operation of source encoder operation. And what is the job of output transducer? Just like what it would contrast what was the work done in the input transducer. Hence, the signal what you had transmitted at the transmission side is now received at the output side. We have taken care of noise immunity. Hence, the noise is also going to be reduced. So, what is the learning outcome then of today's lecture? You have discussed the digital communication system block diagram, which consists of transmitter and which consists of a receiver. Alright, we will take up the next point in the next lecture. Thank you very much. If you have any doubts, you can feel free to discuss immediately in the Zoom meeting which we are going to organize. Thank you very much.